Hello and welcome. We live in a world that's just flooded with information. It's so easy to feel like you're drowning in numbers and charts and all these claims. But what if you had a basic toolkit to make sense of it all? Well, that's exactly what we're going to do today. We're going to build that toolkit piece by piece so you can navigate this world of data with way more confidence.
We have all been there, right? You're staring at a spreadsheet or a news report or maybe just trying to figure out your budget, and you are faced with a mountain of data. The real question is, how do you climb that mountain and get a clear view from the top? That's the problem we're going to solve.
Okay, let's be real. The word statistics might give you flashbacks to a really tough math class, but let's try to reframe that. It's really just the science of taking raw information and turning it into something useful, an insight, story, a confident decision. So think of it less like complex formulas and more like a tool for finding clarity in all the chaos.
And to make this even simpler, the entire massive field of statistics really just boils down to doing two main jobs. It either tells us about what's already happened, or it helps us make a really good, educated guess about what might happen next. So those two jobs give us the two main branches of statistics. On one side, you've got descriptive statistics. I want you to think of this as taking a snapshot of your data. You're just summarizing it to see the big picture of what is. And on the other hand, you've got inferential statistics. This is the forecast. This is where we use that snapshot to make predictions or generalizations about a much larger group.
All right, let's make this real. Imagine a basketball legend like LeBron James. He looks at his scores from the last 7 games and he wants to calculate his average. What do you think? Is he taking a snapshot of the past, or is he trying to forecast the future?
Yep, you got it. That's descriptive statistics. He is simply organizing and summarizing data that's already there. He's describing his performance. It's a perfect snapshot of his recent gameplay. Simple as that.
Okay, round 2. Let's say Mrs. Planis is looking at her electricity bills from this exact same time last year, and she's using them to estimate what she's going to have to pay next month. Is she describing what she already paid, or is she predicting what she will pay?
And there it is. That's the forecast. It's inferential statistics. She's taking a sample of past data to make an inference, a prediction about something that hasn't happened yet. See the difference? One looks back, the other looks forward.
Great. So now that we know the two main jobs of statistics, let's look at the essential building blocks we use to actually do those jobs. These are the core terms you're going to see everywhere, so let's break them down.
First up, we have the population. Now, in statistics, this doesn't just mean people. It means the entire group we're interested in learning about. It could be all the students at a university, every single car made at a factory, or all the voters in a country. It is the everyone or everything, the whole shebang.
Now, as you can imagine, trying to study an entire population is often crazy expensive, time-consuming, or just plain impossible. So what do? We take a sample. A sample is just a small, manageable piece of that larger population. And the key word here, the most important word, is representative. It has to actually reflect the whole group for our findings to mean anything.
The easiest way to picture this is with a pizza. The whole pizza is your population. One slice is your sample. Now, if that slice has a good mix of the crust, the sauce, the cheese, and all the toppings, you can get a really good idea of what the entire pizza tastes like without having to eat the whole thing. Makes sense, right?
So what are we measuring in our population or our sample? We're measuring variables. And a variable is just a characteristic that can change or vary from person to person or object to object. It could be someone's age, their civil status, or their weight. It's the what we're actually looking at.
Now, this is a super important point. Not all data is created equal. To really understand it, we have to classify our variables. And the easiest way to start is by asking one simple question. Am I looking at a quality or a quantity? Is it a category or is it a number? This one question splits all our variables into two big buckets. On one side, we have qualitative variables. These describe a quality or a category. Think civil status, like single, married, divorced. On the other side, we have quantitative variables, which, you guessed it, are measured with numbers, like a person's weight in pounds or their height in inches.
But wait, we can break this down even more. If our variable is quantitative, if it's a number, we can ask another key question to get more specific. Is this something I can count? Or is it something I have to measure?
This gives us our next two categories. Discrete variables are things you can count, like the number of students in a classroom. You can have 30 students or 31 students, but you can't have 30 and a half students.
But continuous variables can take any value within a range, like a person's height. You could be 5'10", or 5'10.1", or 5'10.12. It's measurable on a continuous flowing scale.
All right, we've got our variables all sorted out, but how precisely can we measure them? This brings us to our final set of tools for today, the 4 levels of measurement. These basically tell us how much information our data is really giving us.
I want you to think of these levels like climbing a ladder, where each step up gives you more power. At the bottom, we have nominal data. This just puts things in categories like male or female. They're just different labels. Take a step up, and you get ordinal data. Now we can put things in order, like class rankings, first, second, third. You know first is better than second, but you don't know by how much. The next step up is interval data. Now the space between the numbers is equal and meaningful. The difference between 10 and 20 degrees is the same as between 20 and 30 degrees. But at the very top of the ladder, the most powerful level is ratio data. It has everything else plus a true meaningful zero. Zero height means no height, and this lets us make ratios. We can say someone is literally twice as tall as someone else, a comparison you just can't make with temperature. And knowing this stuff is so important because it tells you what kind of math you're allowed to do.
So let's bring all this home. Why does any of this actually matter? Learning about populations and variables and these levels of measurement, why is it important? Because it's how you turn confusing random noise into a clear story.
Seriously, think about what we just did. You now get the 2 fundamental jobs of statistics, the snapshot and the forecast. You know the essential building blocks, the population, the sample, the variable. And you even know how to classify those variables to understand exactly what kind of information you're working with. This is your starter kit. This is your toolbox for making sense of data.
So the next time you see a chart or hear a claim backed up by data, you're going to be better equipped to look a little deeper. Because statistics, it isn't just math, it's a lens. It's a new way of seeing the world that lets you find the signal inside all of the noise. So the question I want to leave you with is this: what story is the data all around you just waiting to tell?